IK Academy, and I'm delighted to be your host today. I warmly welcome all of you to this Learn with IK live series webinar entitled Solar PV Array Oversizing. For your information, this webinar is organized by iClub by IK, which is our IK Academy community page on Facebook. Also, for your information, this webinar is also being live streamed on our Facebook, LinkedIn, and YouTube pages. Make sure you follow all of our social media portals. iClub by IK is a place for our organization to nurture and create a community of like-minded engineers. We're very happy to have all of you here. So like I said, go ahead, make sure you are visiting our community page and clicking on the join button. Be a part of our community today. Also, don't forget to invite anyone you may know, friends or family that could benefit or could enjoy this sort of content. As a friendly reminder to all of you watching this webinar today, please kindly register yourselves through the Eventbrite page and make sure you won't miss out on any new notifications for our upcoming events and also for webinars like this one. Also, it's important for you to go through the Eventbrite page because it helps us keep a record of your attendance. If you have any questions about our community page or any of our social media pages, LinkedIn or Facebook, for example, the IK crew are standing by to answer any of your questions. And don't forget, when you leave a comment or note in any of our social media pages, be sure to type in hashtag IK Academy. That's hashtag IK Academy, one word. So I'd like to briefly touch on what we do here at IK. So we are a technical training provider, and we have the purpose of transforming engineers into greatness. Our ultimate goal is to build and inspire greater engineers for the world, integrating knowledge as a force for good. Engineers are inventors, designers, and builders of our modern age. Engineers build the world. Hence, we believe in a very simple message: greater engineers, greater world. Neutrality is our priority. We are totally brand neutral with a strict focus on education. Our training programs cover power, maintenance, the environment, building facilities, project management, and more. We are committed to provide the best training experience for everyone. So please like and share this live webinar with those who you think may be interested or could benefit from today's session and future webinars. You may click on the share button and share it directly to your social media pages, or share the link on WhatsApp, Telegram, and whatever instant messaging service that you use. We would greatly appreciate it. Get the message out. So before I invite and introduce our guest speaker for today, I would like everyone to please go ahead and type hashtag IK Academy, one word, in the comment section, just to show your support and for us to know that you're actually here and attending the session. We would greatly appreciate that. So today's webinar topic is solar PV array oversizing. Our invited guest speaker for today, Mr. Channa Silva, will share his knowledge and experience with all of us here. But before we begin with the presentation, I'd like to give more of a background for our guest speaker. Mr. Channa Silva is an international consultant in solar PV with over 10 years of progressive experience in strategic planning, engineering, project development, training, and project management for solar and renewable energy technologies. He holds a Master of Engineering Science in Solar and Renewable Energy from the University of New South Wales, Australia, and a Master of Engineering Management from the University of Technology in Sydney, Australia. He has provided his consultancy and feasibility studies for over 400 megawatts worth of projects worldwide in countries such as Sri Lanka, Australia, Fiji, Bahrain, Oman, Bangladesh, and Maldives. He's also supervised over 50 megawatts worth of solar PV installation projects and worked with the UNDP and as a consultant for ADB in carrying out project feasibility studies. In 2019, he co-founded Solar Consultants, a Sri Lankan-based international consultancy firm where he leads currently as a Chief Technical Officer or CTO. We're very excited to have Mr. Channa Silva here with us today. So Mr. Silva, can you go ahead and unmute your microphone and turn on your webcam, please?
Yeah, sure. Hi, Sean. How's it
Hello,
going?
Mr. Silva. How are you doing today?
I'm good. I'm good. Thank you so much. Thanks
Now
for the
to
introduction.
now to everyone here watching, I want everyone to say a quick hello to Mr. Silva by typing hi in the chat box. And don't forget to type hashtag IK Academy. Now, if throughout Mr. Silva's presentation you have some questions or queries, we would like to invite all of you to type your questions in the comment section at any time on any of our social media portals. And I'll try and read your questions once the presentation ends. And if time permits, we'll try to get through as many questions as possible. Now, it's my pleasure to hand over the session to Mr. Silva. So, Mr. Silva, please feel free to share your slides now, and I will be standing by in the background if you require any assistance.
Sure. So let me share the screen first. Can you see the screen presentation?
Yes, the slides are working.
Okay. Thank you
All
so
right.
much. It's a very good morning to everyone. And thank you so much, Sean, for the introduction. So I'll take it from here and let you know if I require any assistance from you. Thank you so much. So, guys, if you have any questions, just put into the chat box or share through the social media pages. Probably after the this quick session, I would happy to take those questions. So today's webinar is about solar PV area oversizing. So I mentioned one inverter here because when it comes to solar PV area oversizing, inverter plays the major role there. So, discussion points and objectives of today's session is to give an overview about what is exactly solar PV array oversizing and what's exactly the DC to AC ratio and theory behind how to do oversizing and what are the things that you should, look into when you do PV array oversizing. And the third point to, explain why oversizing is required, and probably while flowing the slides, I'm going to take a published case study to explain what are the parameters that you need to, focus on, and especially when it comes to geographies, and also parameters like financial parameters to look into. Because end of the day, everybody is investing on solar PV, especially with the large scale, to get a much higher energy yield, long-term revenue, and get a good project financial return. So in that case, PV array oversizing is a technical thing, but it's directly linked with the financial returns. So that's why most of the investors and the financial personnel interested on this topic, especially. So let's look at with the case study how, what are the things that we need to focus on, and same time so we can quantify some sort of assessment, and we'll also see what sort of negativity so when it comes to solar PV array oversizing. So to get started with PV array oversizing, so let's first brief about what exactly the array oversizing. Array in the sense a series or sort of bunch of modules are connected in series that can be 10 number of modules or thousands number of modules. Just to give you an overview. So basically, array oversizing refers that solar PV system design array that can be go higher, even go to the peak capacity of the inverter. Simply, in simple terms, like getting much more advantage over the inverter capacity. So very simple. If I brief more, you can connect much sort of a bigger scale, higher scale capacity of solar PV array, so the rated power compared to the inverted rated power output. So that's normally a very simple term array oversizing is. So let's straight away look at a graph mentioned here. So in this case, we've taken the consideration of 5 kilowatt inverter with first red color graph connected with the 5 kilowatt array. So it's like matching the array capacities to inverter capacities. But what exactly the oversizing is, connecting much higher capacity of a rated power output from PV array to a selected inverter. So in this case, so the given example is, array oversized by 50%. So no, in normal terms, we say that as 150% oversizing. So connected 7.5 array to a 5 kilowatt inverter. So what is going to happen? So in simple terms, the curve will be much widened, especially in morning hours and in the evening hours. So in that case, the area underneath this power and time curve represents energy. So it means that much higher energy yield during early in the morning and the later in the evening, much higher solar potential, and also since that is connected with much higher capacities, because that inverter doesn't provide a limitation. Inverter does provide sort of limitation. It won't go beyond 5 kVA. It will limit the power output from the inverter itself. So in this case, so this much of energy will be wasted, and we simply call it as power clipping. So power clipped energy represents in this case, but you can have much sort of consistent power, consistent energy throughout the day, since that you already oversized the array invert. So let's look at in very simple terms without considering any sort of technical specification. Very briefly, we can say we do normally oversize PV arrays and inverters by looking at the module price. Let's say that's some sort of the module price when we are comparing the global market, the solar module prices are quite cheaper. In that period of time, maybe we can buy some sort of additional modules to to get much more higher return. Because so in this case, after the inverter, everything it will be fixed cost. Only variable cost is something which connected before the inverter. So if that particular segment is cheaper than it used to be, then sort of having much more addition to get much more high energy yield. So let's look at later slides, how what are the things extra that you need to look into. So simply oversizing also known as DC to AC ratio. It means DC capacity over AC capacity in the sense the inverters ratio, and also array to inverter ratio. So those are like very simple terms which use instead of array oversizing. So if we look at thumb rules and where that when it comes to the global solar PV market, so in general we can say that most of the engineers and other investors normally use 120% to 140% as PV array oversizing factor, without looking at any other factors. But that's what I want to share, that so oversizing is always a location specific parameter, because there are a lot of technical and environmental factors to be considered when it comes to array oversizing. And also there are some other financial aspect to also be looked at. So in that case, even though we practice as like 120% or 20% oversizing to 40% oversizing for the commercial and medium scale and the large scale solar PV application, but still, if you can have your own calculation, you can have your own math done by your own. So that will be helpful, to do and selected much optimum oversizing capacity for a given location. So in this case, uh, the US Energy Information Administration has published some sort of information for like scaling less than 1 megawatt and up to 100 megawatt applications, how they do AC capacity to DC capacity oversizing, which means the array oversizing. So in this case, we've seen that less than 1 megawatt, they're looking at something, 15% to 20% array oversizing. That's happening everywhere, because when it comes to residential and medium scale, most of the cases we are looking at with the technical specification given from the inverter, probably like 10 to 20% oversizing. But when it comes to large scale, people approaching to close to 40%, definitely around 30% and 40% array oversizing. So in this case also represent the same thing. And at the beginning of this solar era in like early 2000, so the array oversizing and the inverters and the technical specification provide the space for like oversizing not go beyond 20%. And so this graph shows until 2016, but still considering the factors they have published that like some sort of 25%, 30% oversizing is being given. But in real life, as I told, like it's 120 to 140%. So some sort of, it's again given on the location specific. If it is more than 30%, most of the places in the world where that, start solar generated energy can be wasted because of the power clipping. But again, as I told, like you do have to do check what exactly the cost addition and also what exactly the additional benefit from that particular situation is. Just simple example, what exactly this particular market says and reference. And so if you look at how this works, for example, let's say if we select inverter's current output. If the array current output, the maximum power point current output is greater than, in case where that if we can assume that current output can be greater than inverter current maximum input, what is going to happen? For example, let's say if we consider a one single central inverter where that IV curve of the entire PV array represents in a single IV curve like this. So inverters algorithm, the maximum power point tracking always try to find the particular instant maximum power point, and it represents maximum power point current and maximum power point voltage. But let's assume that this particular inverter is try to track the maximum power point from the array itself. Let's assume that this particular maximum power point tracking, maximum power point current is greater than inverter maximum current rating. What is going to happen? So simply inverter will shift the power point to a different position to identify and get into that comfortable zone where that inverter can work on. So in this case, so it's trying to reduce the maximum power point current, but in that case, if parallelly the voltage of that particular point is being increased, and how it doing that? By decreasing the efficiency. So let's say that one inverter doesn't provide such feature, so that may be negatively impact on the inverter. But before you do oversizing, first look at whether the particular inverter can accommodate some sort of standard test condition or the rated power of this much of power from the inverter's input. Let's say if it is so when you're oversizing, the inverter does have facility to bring down its efficiency for a certain degree and accommodate that sort of operating point to adjust. But again, it will reduce some sort of power because it cannot take it as the same current input, but the power will be reduced. And again, since that inverter can accommodate, there will be no heat dissipation because it's lowering the efficiency. The only thing here you need to consider is whenever you size your DC string maximum voltage, it shouldn't be exceed the open circuit voltage by the day of your coolest day, the minimum temperature day of the year. So let's say that in case that if you keep oversizing by keep adding, if it is go beyond the open circuit voltage, if there's a day that where that if you encounter, let's say it's a lowest temperature day or standard test condition cell temperature of 25, below that, so that particular day can damage the inverter because you are exceeding some sort of the maximum voltage of the inverter. So in that case, you will have to keep in mind when you do the design, it shouldn't be exceeding, your string length shouldn't be exceeding the maximum voltage of the inverter. So that's you have to keep in mind. And if inverter allows, yes, of course you can have much parallel inverter where that your maximum power point operating current can exceed even the inverter uh, maximum current rating. So if you look at this particular example, they rated for 5 kilowatt inverter with each string of 2.4 kilowatt string, and first first string there won't be any power loss. Red color represents the inverter losses from the inverter, and the blue color represents the system production. So if connected with two, still the losses is very minimal, because that 5 kilowatt inverter connected with 4.8 DC array for two strings. If it is three string, then it reached to 7.2, which is like oversizing by close to 45%. So in that case, loss will be higher. And if it is further higher, so additional benefit is lowering. You can see the gradient. The curve won't follow the path where that it it is planned to be, because it's deviating. So in that case, if you're oversizing more and more, so then it start power clipping. So as we seen in from the graph itself. So like you seen, so in this graph represents in a different sort of representation where that additionally you can see that efficiency coefficient for the two string, it gives like almost 100%, or like close to 1.1 as the coefficient of the efficiency. But when it comes keep adding, keep oversizing more than it's supposed to be, so then it reducing lots of energy, and also overall efficiency coefficient also drop. So this is highly not advisable. This is theoretically some sort of research is being done to see what exactly it looks like, and but when it comes to actual situation, inverters, most of the inverters doesn't provide some sort of facility. So in that case, as I said, first you'll go and look at the inverters input ratings, and after that only you can decide. So what sort of oversizing that you can do. So in this case, so they have considered array cost, different array cost. Array cost include both material and labor. Material in the sense PV panel, mounting structure, and the labor cost. So let's say even though its cost is being higher, still follow the same trend over oversizing coefficient with the cost of per kilowatt hour, which is the cost of the electricity. So in this case, we can see that the cost of the electricity, the cheapest you can get, it means the optimum point for this application particularly is close around 50%. So you can see that the oversizing, they are rated for 210, 250. So someone can, think that, yes, is there a possibility to, have oversized by 250%? Some manufacturers just provide some sort of specific range of products, but by looking at the solar irradiance as a factor where that can go beyond 1,000 watt per square meter, I never recommend to go to that sort of extent, and also the financially not feasible, because that particular range, there's a huge amount of energy is being lost. So as I said, like the standard test condition, the cell temperature is rated for 25-degree, and the irradiance is 1,000 watt per square meter. So in such a situation, it represents the module power, module current, and module voltage as it's defined as the standard test condition. If we take that standard test condition, the rated standard test condition of a such application, 100 kilowatt represents 100 kilowatt itself is as its peak power. But you all know that when it comes to operating condition, it's very difficult to find standard test condition in the field. So let's say in this case, they have assumed that the maximum average cell temperature reach 55. But in Malaysia, the ambient temperature reaches even 35, 35, and that sort of range. So for if you consider the cell temperatures, so it's always have a temperature adder to the ambient temperature. So in that case, temperature can even reach to 60 degree, or like 65, or even 70. In such a situation, what is going to happen? It's derated because of the temperature coefficient of voltage and power. That the power will be reduced for a certain degree. So in this case, for the comparison of standard test condition and the actual operating, 100 kilowatt reach to 77. It means 23% in power will be reduced in actual terms. So let's say if such a case, if we want to select an inverter for this case, 77 kilowatt inverter is more than enough. 77 kilowatt inverter is more than enough cater for the requirement. So any day after that, it'll, for example, let's say 77 still give for the generation output, power output as the maximum point. Early in the morning, even might be much lesser, and later in the evening as well. So in that case, for a given application, if you can identify maximum some sort of temperature for the location and also some sort of realistic numbers, you can identify what sort of percentage reduction that you can do when it comes to selection of inverter. So in this case, 23% oversizing can be easily done because of it's deviating from the standard test condition. So that's why people tends to use a much reduce and oversize the inverters where that practically application it's never performed at the standard test condition ratings. So if we look at in a different perspective, and let's say uh, 5 kilowatt PV array is connected to 5 kilowatt inverter, 5 kVA inverter, the annual energy yield in this simulation goes with 8,260 per annum for that particular given application. As I said, like for a different location, considering different environmental factors, this factor obviously can change. And in this case, this example, it's rated for this month. And let's assume that the same sort of inverter is connected with 6.5 kilowatt array. So the energy output is 10,625, which is like 28% energy increment. So these numbers comes with it's obviously a simulation. Manual simulation is very difficult to find, but you can do a simulation run using a software like PVC, Helioscope, or any other independent software and see. So what would be the energy output? As I said, like, so if you're using a simulation software, it already represents in the simulation reports where that what would be the amount of power clip or the energy is being wasted because of the oversizing factor. So in this case, if you oversize some sort of 30% by the inverter, this much of energy yield is appeared. But for the calculation that they have identified that that will increase 10% of the cost. Why is increased? After the inverter, everything will be fixed. Only it may additionally cost for the 1.5 kilowatt of PV array and some sort of mounting structure with some sort of the labor. But additional gain is 28%. So you can see that considering by looking at these numbers, still you can see that it's worthwhile to go ahead because it's increased 10% and it increased 28%. But since it is a capital gain, capital cost increase, you'll have to work it on with, if somebody really interested to do a project IRR considering the financial, parameters, yes, of course, you can take the consideration of that and see what would be the optimum, point where that, you suitable for array oversizing. And let's look at oversizing in a different perspective. So this particular example is more suitable for countries like Australia, New Zealand, Fiji, and because so end of the day, so let's say if you are connected with a particular rooftop or any other application as a net metering scheme, not like in a feeding tariff. Feeding tariff, definitely the more you feed, you get incentivized. And but if it is come to net metering, just obviously you will have to look at the consumption side, and end of the month it will offset with generation versus cost. But there are some countries where practice as gross metering. Gross metering in the sense you will have to produce some sort of instantaneous power during the day to offset for particular demand. And those places where that if you export and if you generate more, those will be paid at a very different rate. So one of the places that I worked in Fiji, where that they can offset the electricity at particular given instant during the daytime at the rate of Fijian dollar 41 cent. And if they export to the grid, they will only get a feed-in tariff of 15 cents, which is like almost one third. So in that case, it's always challenging and always, advisable if somebody, size the system as per the instantaneous demand. But let's say that your daytime electricity is very, very expensive and still you get a much cheaper PV module, the cost reduced per module, you can do oversizing and do the consistent sort of generation throughout the day. And just forget about the export energy, possibility of the export of the energy. So in this case, PV array oversizing plays a major role where that your daytime electricity is so high and you may require some sort of, consistent power throughout the day. Instead of, for example, let's say if you just, cater with 9 kilowatt inverter with a 12 kilowatt array, maybe you can have, much consistent during like 11 to 1:30, 2 o'clock. But let's say if you oversize much higher, in this case it's more than 60%, maybe in this example it represents from 8 to 4 p.m., where that includes your solar window and the majority of the energy is being generated through that particular window. So as I said again, it's different way of looking at project. For example, let's say, so in this case, it's suitable for a rooftop project and also for related to different application. But again, as I said, like if you are looking at a different perspective of large scale project where that is rated for the feeding tariff, of course you generate more if you feed more and you will get the much more return out of that. So like I said, first you need to look at what exactly the case where that you need to consider, and after that just need to do the particular design based on that. So what are the other benefits that so let's, since that you are looking at here, simply if let's say if you don't look at this case, if you look at only the rated power, if you size with a 100 kilowatt inverter, and so let's say if you look at this one, so you can size with a 77 or the 75 or 80 kilowatt inverter. So you can save some sort of budget from the inverter itself at the beginning. So it reduced the overall inverter budget. For example, you are planning for like a 100 megawatt application. Then can you imagine the what sort of budget that you can save because you are doing much more high oversizing. So when you do a cost and cost saving calculations, you have to do those calculations as well. And same time, so let's say that since that you are planning to install a limited number of inverters, so then obviously you can save some sort of space, as well as yes some sort of cost saving from labor and also other inverter mounting mechanisms. And also let's look at if the particular application is with east to west PV array. So why most use east to west PV array insulation, even though it's deviating little bit of extra from the optimum point, but still if there's a application where that area is limited, so in that case, most of the cases modern day we've seen that east to west array installation, and also since it's close by, the mounting structure budget also very limited, because one to one it's provide the structural integrity, the structural strength. So in that case, it saves some sort of budget in that. So in such application, you can do much more oversizing by saving in different perspectives. So as I said, like that's what. So when you are doing a cost benefit analysis, so you'll have to think about not only about the module prices, but also the structural mounting structure cost saving and labor space saving and space cost for the space, and all these factors to be considered. So in this case study example, so SMA has published this case study. So in this red line, it represents the fixed cost. What exactly the fixed cost is? Fixed cost is cost from the point of inverter. So starting from inverter, AC side protection, AC side combiner boxes, switch gear panels, step-up transformers, and the grid lines. If there's a substation, so if it is 100 megawatt, maybe distribution line and some sort of transmission lines, maybe substation, new substation cost, all include for fixed cost because cost won't change even though you do the oversizing. So variable cost in the sense, again, the total, the DC side, the DC system, such system can be variable because of the adding more panels. You may require more number of parallel strings, additional DC cables, and additional mounting structure, additional land space requirement, and labor requirements. All these can be a variable cost. So in that case, when you do oversizing, that is linearly increasing. So as you can see, even though the fixed cost for the application, and since this is variable, the total sum of the cost also being varied with oversizing factor. So PV generator size means the DC to AC ratio coefficient oversizing factor. So in this case 100%, it means there will be no oversizing, and in this case 20%. And same time, you can see that the revenue early stage of the curve, it's keep increasing. After that, the gradient will be reduced because it start losing energy even though revenue is increasing. And also, if you look at the performance ratio curve, by looking at it, it's a purely a technical one. Is by looking at what would be the optimum. Most of the cases we've seen that around 30% or 130% oversizing factor provides much sort of technical oversizing for the technical people like us. We preferred somewhere around that. But when it comes to financial perspective, there are some other factors to be considered. For example, let's say not only the project cost, but also considering variable cost and fixed cost, you can take to identify some sort of total project cost against the return. What would be the return for kilowatt hours? Different part of the world, different rate is being introduced. When it comes to rooftops, still around most of the cases we've seen that 10 cents or more than that in different part of the world. And when it comes to ground solar, the lowest reach is close to 1.5 or 1.6 USD cents per kilowatt hour. In Malaysia, I think somewhere range of 3-4 cents, as I know. So probably I remember that during my last training program in Malaysia, so we discussed some sort of information like this, and I don't exactly remember, but somewhere a range of that, and also to be considered interest rate, the particular country's interest rate against the project, the contract period, PPA period, that can be 19 or 20 or 25-year consideration, and you can do the calculation for the net present value and the calculation for the internal rate of return. So basically, by looking at these two financial parameters, financially where that project is going for the give the maximum financial returns, where the project financials become optimum, even though your technical feasibility, technical optimum point somewhere is around at the point of 30%. But for definitely from the investors perspective, people looking at some sort of comfort zone and the optimum point from the financial return. So to have that, to get the benefit, that you will need to identify the cost and the additional cost requirement for each, and simulated energy yield, specific yield for each point, and plot the graph based on financial parameters for the feed-in tariff and the interest rates, and then you can identify what would be the optimum financial return for that point. So, do you think if we differentiate, if we differentiate it with uh, differentiate with the location, what would be happen? If you differentiate it with the location specific irradiance, minimum temperature and the maximum temperature, it's definitely change. Again, it will be impact on oversizing, because the case is the average radiance, minimum temperature and maximum temperature. If let's say assume that if the maximum temperature is much higher compared to another location, then sort of energy is being lost. That particular location is quite higher. So in that case, it's okay, it's fine with oversizing where that the maximum temperatures are much higher. So likewise, the minimum temperatures. So average ambient temperature always to be considered, and average radiance. Where that different countries experiencing winters and low temperatures and low radiance seasons. For such a places, if you can oversize more, but first you look at the minimum temperature and where that open circuit voltage shouldn't increase the maximum voltage of the inverter window. By looking at it, it's changing location. Again, the oversizing factors can be changed. And also, again, as I said, like should look at different parameters like interest rates, the PPA rates, and the feeding tariff, and also some sort of cost structure. So in this case, different location is being considered with NPV and a PV array oversizing factors. Some locations overhead costs are very high, and the insulation cost and the grid line cost are very high. For example, places like in Japan, the costs are so high, and also at different places, some sort of in Europe or in Australia, compared to Asia, the cost is can be quite higher. So in that case, oversizing of to a different location, maybe oversizing for different location can be changed. If the fixed cost is too high, it's always advisable to go ahead with much higher oversizing factor, because that can average your cost of electricity, cost per kilowatt hour compared to where that fixed cost is lower. So in this graph, we are looking at the normalized yield versus again some sort of consideration with fixed tilt and tracking bar, and you can see that from some sort of point, probably it's around 1.3, the curve won't follow the gradient where where the ideal runs. It deviating, it diminishing return start from probably around this point of curve. So again, as I said, like, so once again, just wanted to make sure that always by looking at the location specific parameter instead of going into. So what would be the negative impacts? Probably, like one study I found from research that this the study is done for Denmark, and what exactly it is, for the lower irradiance level, the lifetime of the inverter, the performance will be much lower, and do much oversizing. Maybe they have selected some sort of specific inverter, so in that case, it's reduced the lifetime and the reliability. So as I said, like when it comes to inverters, they specifically mention what would be the maximum DC input, that power input that they can have. For example, let's say we do small scale inverters. So they nominated for maximum. Most of the cases we have seen that the very small scale, majority of the inverter represents probably around 20% of the oversizing. But when it comes to bigger scale, large scale, sort of, central inverters, they do have easily they can oversize more than 50%. So they allow to do that. The inverter allows to do that. But some cases with the restriction, as I said, from the voltage or the current perspective, so any sort of efficiency curve and consideration, maybe some doesn't provide. In such a case, if you oversize, that may directly negatively impact on the lifetime and the reliability. So in a nutshell, so let's see. So we have discussed lots of factors. So let's if we look at why people tends to use much higher DC to AC ratio, basically considering environmental factors like, let's say, so this uh, image shows uh, represents the loss breakdown from a PVC simulation for a given installation. So you can see that the temperature loss is 12.3. Normally, the performance ratio for average PV system ranging from 75 to 80%, but it's half of the uh, percentage loss reduced because of the temperature. So that particular given location, temperature profiles are much higher. Let's say average maximum temperatures are higher. In that case, the loss from the temperature is quite higher. So in that case, for particular location like that, going for much oversizing is more advisable than somewhere else where the average temperatures are quite low. And also, let's assume that if the soiling or the dirt or the pollution factor is high, and it's keep losing your energy because of that, yes, of course, it's advisable to go for higher DC to AC ratio. And also, let's say that if it is deviating from optimal, like let's say if you cannot find, if it is a rooftop project where that it's not provide optimal orientation and the tilt angle, of course you can take the consideration of much higher uh, much higher DC to AC ratio. And of course there can be mismatch losses. And also basically by looking at the load to get the load, and if again if the returns from the kilowatt tower is lower, then definitely you will have to think about that. And also, as I said, like by looking at different financial parameters and interest rates, the project cost, again changing the fixed cost and all, by looking at higher revenue in long run, and also looking at the incentive. Some countries just provide some sort of incentive based on the performances. So in that case, people tends to use much higher because its long-term revenue will be impact on that. And same time, module is keep aging. After 10 years time, you can still get much higher benefit if you oversize at the beginning because uh, so like I said, it's not by looking at the module cost, but also by looking at some sort of technical parameters and some sort of the financial parameters. And why lower DC to AC ratio? If you look at that, of course, lower temperatures. And one of the main thing is if the high elevation, the place where that close to mountains and those type of high elevation location, high altitude location. So those locations, irradiance is quite higher than a standard test condition. For example, standard test conditions rated for 1000 watt per square meter. But we know in practical world where that we experience more than even 1000 watt per square meter cases as well. So in that case, if goes to the much high altitude, then the radiance can be higher. So that produce much more higher current than the rated current. So in that case, that has to be taken care of. And also technical and product constraints. Again, one final thing, investors request. Probably some investors doesn't want to oversize. I don't know what exactly, it may be a lack of knowledge or whatever the reason. Some doesn't want to do that. Some require some sort of safeguard their products, and there are myths going on with oversizing in the industry. And because of that, some doesn't want to do that. So that's some sort of, in a nutshell, these are the parameters that you need to take the consideration. So that's it for the webinar. And also one of the final announcement from my end. So we are going to conduct an advanced solar PV training program in Malaysia in first week of August under IK Academy. So parallel to that only, we organize this webinar on PV array oversizing. And also I'm looking forward to do an actual cost benefit analysis study, and show the class where that what are the parameters which I highlighted right now, how to do a cost benefit analysis in actual, and also a location specific calculation also to be planned to be taken. So that's why I just want to make quick announcement on about that particular training program. I think better you follow the IK Academy websites or the social media page to get more information about the short course, or else you can contact IK team for that. Okay, thank you very much, guys. Thank you for being a wonderful audience. And if you want to reach, I'll share this presentation with you. Just you can drop me an email anytime. And probably if you have any question, I would very much happy to answer. Thank you. Thank you so much.
Thank you very much to Mr. Silva for his presentation today. And also, yes, if you're interested for any of the courses related to PV solar, and of course, any of Mr. Silva's courses, please contact the IK team and we'll be very glad to help you. Now, Mr. Silva, we do have some questions from our participants. So I'd like to start with the first one. Now, one of the questions was, why is oversizing more interesting in today's market conditions?
Okay. Yeah, I think the same thing already will be discussed. So basically, the reason why today's market is we are seeing at the module prices are coming down. By looking at straightforward, yes, of course, if we just keep other factors aside, mainly people interested by today is because you get much sort of cheaper DC side. The cost per watt is quite cheaper than it used to it year ago. So let's say that year and a half ago, the module cost was around 30 cents per watt, but nowadays it's touching again 20 cents per watt. So in that case, you can bring down your average cost of electricity because your fixed cost is there, the variable cost is not that so expensive. So in that case, that's a major reason that I've seen. Yeah.
Okay, I see. All right. And I do have another question here, and this participant would like to know which markets are most suitable for PV array oversizing?
Okay. So basically, as I said, like first, before you do oversizing and to identify the optimum point, you just need to identify what your project cost is and what would be your energy in these. So let's say you keep oversizing, so it's only add on that particular DC side cost factors only, but you will gain additional benefits. So if your fixed cost, from fixed cost in the sense, the cost involved after the inverter is quite high, market like your insulation labor is very high, overhead costs are very high, the grid line costs are very high, and those places it's more suitable to consider. Let's look at if the module prices are super cheap and also labor rates are super affordable. So like if some places compared to that particular point where your overhead costs are high, the places like Japan, Australia, some sort of some part of Europe, those markets are more suitable because to bring down your total average cost, you can keep increasing your variable factor and see how it moves. So in that case, most suitable markets like you're aware that your fixed cost is so high. I think much relevant to here. I think compared to other markets, the Malaysia's installation cost and the labor cost is quite affordable. So probably compared to other part of the world where that countries which I highlighted, maybe in that case the Malaysia is so lucky that have much average range of cost. So yeah, some sort of
Okay, thank you. So, Mr. Silva, another question here. What are some of the design aspects that they should look into when it comes to array oversizing? So, what are some important design elements to consider?
So the first thing that you need to look at is the inverter specification. Inverter specification, you just need to look at the inverter DC side inputs, whether it's allowed for some sort of arrangement, and always advisable if it is a sizable project and if you do go beyond thumb rule rates are like 25-30% of oversizing, always send to the inverters team to get a design review on that. That's number one. But when it comes to design factors, yes, always it shouldn't exceed open circuit voltage of the string, not go beyond the inverter input. And the second thing is by looking at the current input of inverter and also a rated parallel total current which sent to the DC system. Those are the two systems. Other than that, everything is can be used as the normal standard way that you are, when you do the design. Basically, these are the factors to be considered.
Okay, very good. I have a more specific question here from one of our participants, and they would like to know, do you have any examples of or a case study for oversizing and bifacial single axis panels in areas with high solar radiation for very large PV power plants? So he's talking about 600 megawatts with 2.5 megawatt blocks with 10 key stations. So this is a very specific technical question.
Yeah. So thanks for sharing that question. And I think just not to promote or the market our training program, which to be done on August. Yes, I'm looking for at the moment I don't have, but we are planning to discuss some sort of actual case study which relevant to condition in Malaysia in considering different scenarios like we can you of course consider for 5 megawatt or 10 megawatt or 2.5 megawatt block and do a actual cost benefit analysis, just not to market the training program, but that's also part of the agenda. Probably if you reach to a IK team, you can get more information about the course. I think it's scheduled on first week of August as an in-person training to be done in Malaysia. So at the moment, I don't have and also it's the time is up right now, and probably I'm looking forward to discuss some sort of specific one.
Yes, you want to hear more from Mr. Silva regarding this, please join our training program and you get to spend more time with Mr. Silva himself. So I do have another question here, a concern about oversized PV arrays. Can it do array damage to the inverter and reduce the module lifespan?
Yeah, of course, that can be happen. That can be happen if inverter doesn't allow to oversize. So that's what I said. I've seen very small scale inverter where that it doesn't provide some sort of even 10-15% of oversizing. So in that case, it's specifically related to, even though all the factors are matched, but it's specifically related to the inverter that you're going to use. So in that case, by looking at the inverter specification is the first thing that you need to do. So the second thing is the other factors. So in that case, of course, you will have to look in that. Otherwise, that will impact on the performance lifetime, and that may even lead to a damage of the inverter.
Okay, very good. And Mr. Zhu, another question here, last question actually, also another concern because we have some participants from hotter climates and they want to know, will there be any overheating issues with the module during the hot season? So when temperatures are high.
Yeah, basically during hotter, the efficiency because of the temperature factor, it's reduced. So in that case, it's allow much more oversizing. But third party incident can create different hotter hotspot for the array itself, but oversizing won't provide, except that you properly design your DC side protections and by looking at the DC current input with the inverter current input. But again, as a conclusive note that I just want to highlight that if the hotter temperature, yes, of course, it's allowed much more higher, oversizing. So that's it, I guess. So I'll give one final remark from my end. Thank you very much for the participants who's participating, and also Sean, thank you so much, and also IK Academy, thank you very much. I'm looking forward to conduct the in-person training program in August. And thank you very much. If you have any questions, just you can reach me, drop me an email. I'll send the presentation by today, and I sharing my PPT with IK Academy by today itself. Okay, thank you so much, guys.
Thank you very much to Mr. Silva for fielding all those questions, also for his presentation. And we hope that all of you here attending today have gained some knowledge, and also the responses have been satisfactory and that you're content with them. However, as mentioned before by Mr. Silva and myself, if you'd like to spend more time with Mr. Silva and get to know more of his insights and more of his experience, you're more than welcome to join us in our training sessions, where you can have, ask him more detailed questions and case studies. Now, for the rest of you, don't forget to type hashtag IK Academy, one word, and just any closing remarks you have about the session today. Now, to show your appreciation, we would really appreciate it if you could leave a thank you note to Mr. Silva on our Facebook, LinkedIn, and YouTube pages. Really would like to see you show your support for our guest speaker for today. Now, as a reminder, kindly follow our Facebook pages, LinkedIn, Instagram, also our YouTube channel as well. And more importantly, iClub by IK to get all the latest news for our upcoming IK Live webinar series and other content sharing opportunities, right? And last but not least, please check your emails for a link and or barcode to retrieve your e-certificate. Now, you would have had to register via the Eventbrite site, like I mentioned earlier this morning, and you have to claim it within 3 days. We hope to see you again, and that's it from me. I've been Sean from IK Academy on behalf of Mr. Silva. Thank you very much for joining us, and we hope to see you soon. Goodbye, everyone.